Good evening, students. So today we are going to start with a new chapter, that is electrochemistry. Okay, so what do you mean by electrochemistry? Yes, what do you mean by electrochemistry? So electrochemistry. Okay, so the cell is mainly of two types. First one is galvanic cell and the second one is electrolytic cell. Okay. So what do you mean by galvanic cell? Yes, what do you mean by galvanic cell? Yes, anybody, what do you mean by galvanic cell? So galvanic cell, it is an electrochemical cell that converts chemical energy of spontaneous redox reaction into electrical energy. Now, what do you mean by redox reaction? Redox reaction means what? Wherein reduction and oxidation will undergo, okay, it will go at a one time. Okay, so in a one reaction only, simultaneously oxidation and reduction will takes place. So what do you mean by galvanic cell? Galvanic cell, it is an electrochemical cell which converts the chemical energy of a certain redox reaction into electrical energy. Okay, so this is about the galvanic cell. Then what do you mean by electrolytic cell? Electrolytic cell. So electrolytic cell is what? Electrolytic cell. So in electrolytic cell, what is happening? The electrical energy, it is converted into chemical energy or vice versa. Okay, in electrolytic cell, what is done? The electrical energy is converted into chemical energy and vice versa. Okay, so first we are going to start with what is electrochemical cell. So what do you mean by electrochemical cell? Electrochemical cell that converts the chemical energy into electrical energy. So we'll study some of the terms. Okay, so what are anode? Anode is what? Anode in electrochemical cells, the anode is the electrode at which the oxidation takes place. What do you mean by oxidation now? Oxidation means what? There will be loss of electrons, right? Loss of electrons. So this is called as the negative terminal. So the negative terminal, now you know when you take a battery. Okay, so for a battery there will be positive terminal as well as the negative terminal, right? Now what is anode? Anode is what? In this, the it is the electrode at which the oxidation takes place. There will be loss of electron at this electrode, and this is a negative terminal. This is called as what? This is called as negative terminal. So the negative terminal is called as anode. Next is cathode. What do you mean by cathode? So cathode, it is the electrode at which the reduction takes place. Okay. So in the electrochemical cells, The cathode is what? It is the electrode at which the reduction takes place. Now, what do you mean by reduction? Reduction is nothing but gain of electrons. Okay, at reduction, what happens? Gain of electrons. There will be gain of electrons. So this is called as the positive terminal. So anode is a negative terminal, cathode is a positive terminal. So whenever you want to calculate the EMF of the cell, okay. So EMF of the cell can be calculated as E cathode minus E anode. That is E positive minus the negative. So E cell can be calculated as E cathode. Okay, the cathode, E cathode minus E anode. So remember this electromotive force. What is EMF? EMF is nothing but electromotive force. So electromotive force of the cell, okay, so electromotive cell, uh, it can be calculated as E cathode minus E anode. Next is the thermodynamic efficiency of the cell. So thermodynamic efficiency means how well the how thermodynamically well the cell is there. Okay, how it is working. So it is a ratio of Gibbs energy change to the enthalpy change of the cell. So this will be studying further. Okay, this is just the small terms in the small short forms. Okay, they have given the key points which you'll be studying. Then what is electrochemical series? So electrochemical series, it is the arrangement of various elements. So when you arrange the various elements in the increasing order of their reduction potentials. So reduction potentials will be given of all the metals. Okay. So when you arrange the elements in the increasing order of their reduction potential, it gives rise to electrochemical series. Okay. Next is electrolyte. What do you mean by electrolyte? A substance that dissociates in solution. Okay, a substance that dissociate in solutions, okay, to produce ions and hence conduct electricity. Suppose electrolyte like NaOH I have taken. Okay, if I take NaOH and if I add into water, what I have done? Okay, when what I've done, so I've taken NaOH and I've added into water. Now, what is happening when you have added NaOH into water? This NaOH will split into Na plus ions and OH minus ions, and it will start conducting. It will start conducting electricity when the substance, when any substance, suppose NaCl. If I add NaCl in water, what will happen? It will dissociate. It splits into Na plus ions and Cl minus ions. So when it splits into the ions, what will happen? There will be conduction. There will be conductivity. It conducts electricity in a dissolved state or in molten state. So this is the role of the electrolyte. Next is molar conductivity. What do you mean by molar conductivity? Suppose the conductance of a solution, which contains 1 mole of electrolyte. So the electrolyte, it should have 1 mole. Okay, the conductance of the solution, it contains containing 1 mole of the electrolyte is placed between two parallel electrodes 1 centimeter apart. It gives rise to molar conductance. Okay, so what is happening here? So a conductance of a solution containing 1 mole of the electrolyte, it is placed between the two parallel electrodes, which is 1 centimeter apart. It gives rise to something called as molar conductivity. Next, we are going to study about electrochemical cell. So now we are going to study in deep, okay, about the electrochemical cell. So electrochemical cell, as we have discussed in the key terms, what do you mean by electrochemical cell? Electrochemical cell, it is an electrochemical cell can generate electrical energy from the chemical reactions occurring in it, or use electrical energy to supply to facilitate the chemical reaction in it. So electrochemical cells, okay, it is a device. Electrochemical cell is what? It is a device, okay, in which what is produced? Electricity is produced by using the spontaneous redox reaction. Okay, and thus it is called as electrochemical. So what is happening? Chemical energy is converted into electrical energy, and this electrical energy can be used. Okay, so the examples is Daniel cell. Okay, electrical cell. Now, what are the types? Galvanic cells and electrolytic cell. So galvanic cell, what is happening in galvanic cell? The chemical energy of a spontaneous redox reaction is converted into electrical energy. And electrolytic cell, in electrolytic cell, what is happening? In electrolytic cell, electrical energy is used to carry out a spontaneous redox reaction. Okay. So these are the types of electrochemical cells. So one is the galvanic cell, another is the electrolytic cell. So you can see the galvanic cell here. Yes, the down picture of galvanic cell. So two beakers are taken. In one beaker, what they have added? Oxidation means what? One substance which is undergoing oxidation is added in one beaker, and in another beaker, one substance which is undergoing reduction is added in the another beaker. Now, zinc. Okay, so what they have done, zinc anode. Zinc is the anode, which is a negative terminal. So zinc anode is dipped in zinc solution. So zinc anode is dipped in zinc solution, and here cathode electrode is dipped in cathode solution. So cathode is your positive, zinc is the negative. So what is done when the electrons? So there is a salt bridge. Salt bridge. It pass. What is that? It connects. It connects the two solution between the oxidation and reduction. So when the electron is when the switch is on, the electron as the current flows in one direction, electron will flow in the other direction. Okay, so this is the galvanic cell. So this is the working of the galvanic cell. Okay, so anode, okay, that is zinc anode is dipped in zinc solution, and that is Ag. Okay, so and Ag, that is silver. Okay, silver electrode is added into what? Silver electrode is dipped into silver solution. So this is the working of electrolytic cell. So next we are going to see the galvanic cell. So galvanic cell, it has a electrical potential of 1.1 volts. Okay, so suppose if an opposing potential of 1.1 volt is applied to this cell, if the opposing potential equals the electrical potential of the galvanic cell, then the flow of the electrons will stop. So what is happening? So this galvanic cell, it has a electrical potential of 1.1 volt. So what is happening in the galvanic cell? What is done? The chemical energy is converted into electrical energy, right? So when the galvanic cell is working, so the electrical potential which is produced by the galvanic cell will be 1.1. Suppose the electrical energy is flowing. Okay, now to oppose this, now if I apply one more than 1.1 volts, so if I apply 1.1 volts, okay, so if I apply to this galvanic cell, so opposing potential is, if it is applied, then what will happen? The opposing potential will be equal to the electrical potential of the galvanic cell, and the flow of the electrons will stop. So if the electrical potential is 1.1, so if I put a 1.1 opposing potential, then the flow of the electrons will stop in the galvanic cell. So when the reaction will stop, then if the reaction stop, what will happen? If the reaction stop, then the current flow through the cell also will be stopped. So whenever a galvanic cell is produced, okay, galvanic cell, what is the working? Chemical energy is converted into electrical energy. So when it is producing chemical energy, that is electrical energy, the electrical potential will be 1.1 volts. Okay. If I put a higher volt, okay, if I put 1.1 higher volt, what will happen? It will oppose, it will stop. It will stop. Okay, when the flow of the electrons will stop, because you know that the each other. If the current is flowing in one direction, the electrons will be flowing on the other direction, right? So when the electrical potential is opposing the main potential, what will happen of the galvanic cell? Then the flow of the electrons will stop, and however the current flow through the cell also will be stopped. So for any further increase, if you want to increase the in the external potential, again what you have to do, you have to start the reaction, but you have to start the reaction in the opposite direction. So you can see the different diagrams here, right? So this indicates how it is. Okay, so what is done here? Zinc, in the first diagram you can see the zinc electrode is dipped in zinc sulfate solution, and cathode that is copper cathode copper, which is cathode. Okay, it is dipped in copper sulfate solution. Okay, here what is happening? The external energy electrical potential is less than 1.1 volt. Okay, it is less than 1.1 volt. So the energy, the electrons and the these are in opposite to each other. Then in the second direction, if the external energy is equal to 1.1, okay, 1.1, what will happen? Then there won't be any no flow of electrons or current. Okay, so external energy is equal to the energy which is opposing. Okay, so then there won't be any chemical reaction taking place. Now, if you apply the external energy more than less than 1.1, okay, so here you can see if you apply more than 1.1, what will happen? The electrons will flow from copper to zinc. Okay, when it is more than 1.1, what will happen? The electrons will flow from copper, that is from anode to the cathode, and the current will flow from zinc to copper. You know that what will happen? The current and the electrons will flow in opposite direction. So if you apply external EMF more than 1.1, then the electrons will flow from copper to zinc and the current will flow from zinc to copper. And zinc will be deposited at zinc electrode and copper will be dissolved at the copper electrode. And when you have that is electrical potential less than 1.1, what will happen? Electrons will flow from zinc rod to copper rod and current will flow from copper to zinc. Okay, zinc to copper, and what will happen? Zinc will dissolve at anode and copper will deposit at cathode. Okay, so these are the things which we have to understand. Okay, about the galvanic cell. So when you have a proper electromotive force, that is a electric potential. So now we are going to discuss about the differences between the galvanic or the voltaic cell. So galvanic cell is also called as the voltaic cell. Okay, galvanic cell is also called as a voltaic cell. And what is electrolytic cell? So we are going to see the difference between the galvanic and the electrolytic cell. Now, what is galvanic cell? It is an electrochemical cell in which the chemical energy is transformed into electrical energy. What is electrolytic cell? Electrolytic cell is an electrochemical cell in which the electrical energy is converted or transformed into chemical energy. Now, in galvanic cell, the chemical energy is converted into electrical energy. What is happening in galvanic cell? In galvanic cell, the chemical energy, okay, chemical energy is converted into electrical energy. What about electrolytic cell? In electrolytic cell, what is happening? The electrical energy is converted into chemical energy. Now, whenever you are discussing about the galvanic cell, okay, the positive terminal is cathode while the negative terminal is anode. And in case of electrolytic cell, the anode is positive. Okay, when you're considering the electrolytic cell, the anode will be positive and the cathode will be negative. Okay, so this is the difference between electrochemical and that is galvanic and electrolytic cells. So few more differences. When you have a galvanic cell, electrons being negatively charged, they flow from anode to cathode of the galvanic cell. In electrolytic cell, electrons flow from cathode to anode in a electrolytic cell. So it is a huge difference, right? So this will flow from anode to cathode. Here it flows from cathode to anode. A spontaneous chemical reaction occurs in galvanic cell to release electrical energy. So what is happening? A spontaneous chemical reaction occurs. It will occur in a galvanic cell when you are releasing the electrical energy. In electrolytic cell, non-spontaneous chemical reaction takes place. Okay, spontaneous, and what do you mean by non-spontaneous? Can anyone tell me what do you mean by spontaneous and non-spontaneous? What is the major difference between spontaneous and non-spontaneous? Yes, spontaneous and non-spontaneous. So spontaneous reactions means what? They takes place without any external factors. Okay, if you it does not require any external factors. Okay, it does not require any external factor for carrying out the chemical reaction. And in electrolytic cell, okay, what is happening? Non-spontaneous means what? It requires a some this. Okay, it requires some external force. So when it requires some external force, okay, they are in the electrolytic cell, and then the non-spontaneous reactions takes place. Now next is galvanic cell. Does not require external voltage source. So in galvanic cell, it does not require any external voltage source. And in no, this electrolytic cell, an external voltage is required. Okay, then in galvanic cell, electrical energy flows from cell to the external circuit. So what happens in case of galvanic cell, the electrical energy, it flows from the external circuit, from the cell to the external circuit. And in case of electrolytic cell, okay, in case of electrolytic cell, the electrical energy, it flows from external circuit to the cell. Okay, so these are the differences. Some more. Galvanic cell, it requires two separate cell containers that forms two half cell, which is connected by a salt bridge. So we have seen this diagram of galvanic cell, right? So in the two different beakers, two different solutions are there, and respective electrodes are dipped, and it is joined by a salt bridge. Then in case of electrolytic cell, a single container is taken, which forms the complete electrolytic cell. Then in galvanic cell, ions will discharge at the cathode and consume at the anode. In case of electrolytic cell, both the electrodes of an electrolytic cell, they discharge the ions. Okay. In galvanic cell, the oxidation reaction takes place at anode, while the reduction reaction takes place at cathode. Then in case of electrolytic cell, the oxidation reactions occur at the cathode and the reduction reactions occur at the anode. Galvanic cell are used as a source of electricity, which is used in batteries, etc. Electrolytic cells are used in electrolysis for purifying the metals, etc. So these are some of the differences of galvanic cell and electrolytic cell. So next is electrode potential. Okay, electrode potential. What do you mean by electrode potential? The potential difference between the metal and its ions. Okay, now you know the electrode is nothing but the metal. Electrode is nothing but it is made up of metal and it is dissolved in the ions. Okay, so electrode potential is the potential difference between the metal anode and its ions. Okay, then next is what is standard electrode potential? When the concentration of all the species involved in a half cell is unity. When the concentration of the species, so when the concentration of the given species in the which is involved in the half cell is unity, then the electrode potential is known as the standard electron potential. So what is standard electron potential? In that, the concentration of all the species which is involved, okay, in the half cell reactions will be equal to unity. What do you mean by unity? Unity is equal to 1. Then it is called as standard electrode potential. What is oxidation potential? The tendency to lose electrons. Okay, tendency to lose electrons is called as oxidation potential. Then reduction potential, the tendency to gain electrons. Now what is cell potential? Cell potential is what? The potential difference is caused by the ability of electrons to flow from one cell to the another. That is delta E is equals to E cathode minus E anode. Okay, what is electromotive force? Electromotive force is the maximum potential difference between two electrodes of a galvanic or the voltaic cell. Okay, electromotive force, EMF. Okay, it is, how do you calculate EMF? EMF is equals to E cathode minus E anode. Just now we have seen, right? So E cell is equals to E right minus E left. So the cell which is present at the right side, that is E cathode minus the E anode, which is on the left hand side. Then overall cell reaction. What do you mean by cell reaction? The overall reaction of any electrochemical cell is nothing but the cell reaction. It requires the equation in which is an addition of two electrode reactions with the cancellation of electrodes. So overall cell reaction, cathodes plus anode by the cancellation of electrons are called as what? It is called as the cell reaction. So these are few terms which we are going to use in the uh, just a second. So next few definitions we'll be studying. Okay. So cell representation we'll discuss in some moment. So next is, so just now we have discussed about the electrolytes. So what do you mean by electrolytes? So electrolytes, these are the substance which conduct electricity when you are decomposition. Okay, when it gets deposited or when it gets discharged into its ion, it's called as what? It is called as a electrolytes. Suppose the acids. Suppose if I take the examples of acid. Okay, what are the acids? Okay, which are the acids now? Okay, so suppose I take HCl. So HCl, HNO3, nitric acid, okay, H2SO4. So these are the acids which you are going to use. So suppose these are the acids. So if I add these acids into water, okay, now this will split into H plus ions and Cl minus. So whenever this ions, they will split or they get discharged into the aqueous solution, they conduct electricity. So when they conduct electricity, then they are called as what? They are called as the electrolytes. So either they will conduct electricity in molten state or in aqueous solution. Okay. So after the passing of electricity, they will conduct electricity. Okay. So an electrolyte, so it conducts electricity. So basis. So these are the examples of acid. Now, which are the bases which conducts electricity? NaOH, then KOH. What is KOH? It is potassium hydroxide. Then NH4OH. What is NH4OH? It is ammonium hydroxide. So these are some of the bases which conducts electricity. Then which are the salts? Which are the salts? Yes, which are the salts? Salts like NaCl. Okay, then potassium nitrate, then copper sulfate. Okay, then ammonium chloride. So these are some of the salts which conduct electricity. Okay, in the molten state or in the aqueous state. Now, what are non-electrolytes then? What do you mean by non-electrolytes? What do you mean by non-electrolytes? Non-electrolytes means what? It does not conduct electricity. So whenever you have non-electrolytes, so these what you say non-electrolytes, okay. So these are the substance which does not conduct electricity. It does not conduct electricity. Okay, it does not conduct electricity. So these do not conduct electricity. For example, what can be the example? Either in the aqueous solution or in the molten state. Okay. So can you tell me the example? Suppose cane sugar. Okay, cane sugar, then urea, then ethyl alcohol. Okay, ethyl alcohol, then benzene. So these are some of the examples of what? Some of the examples of non-electrolyte. So it does not conduct electricity. Okay, it does not conduct electricity. So non-electrolytes are the substances which does not conduct electricity. Uh, and generally the electrolytes which we have studied, okay, electrolytes, they will be ionic in nature. Electrolytes will be ionic in nature, and non-electrolytes will be covalent in nature. They will be covalent in nature. Now, this electrolytes, okay, which we have studied, electrolytes. So these electrolytes are again of two types. One is the strong electrolytes. One is the strong electrolytes. Then another is the weak electrolytes. Next is what? Next is the weak electrolytes. Now, what do we mean by strong electrolytes? The electrolytes which ionize completely. So here, the electrolytes ionizes completely. It ionizes completely. Okay, it ionizes completely in the aqueous solution, even at the moderate concentration. Then they are called as strong electrolytes. Then what do you mean by weak electrolytes? What do you mean by weak electrolytes then? So weak electrolytes are what? It does not ionize completely. It ionizes incompletely. It does not ionizes completely. It ionizes incompletely. Okay, incompletely it gets ionizes. Then either in the aqueous solution, so it is called as weak electrolytes. So I can give you example as acetic acid. This is acetic acid and this is HCl. Okay, so this is the main. So we have studied about electrolytes, non-electrolytes, types of electrolytes, strong electrolytes and weak electrolytes. Strong electrolytes, it ionizes completely. Okay, these are the substances which ionizes completely in aqueous solution at moderate concentration. Then they are called as strong electrolytes. What are weak electrolytes? These are the electrolytes which ionize incompletely in aqueous solution at moderate concentration. Then they are called as weak electrolytes. Okay. So this is about the electrolytes. Then we need to discuss few more points. The second. So there's something called as conductors, insulators, and semiconductors. Yes, do you know what do you mean by conductors? This you have studied in physics. Yes, what do you mean by conductors, insulators, and semiconductors? So what do you mean by conductors? So the substances which allow the passage of electricity to pass through them. Okay, the substances which allows the passage of electricity to pass through them is called as conductors. So example, the metals. Okay, metals are the examples of conductors. Then the alloys, then the graphite. Okay, then some polymers. Okay, some polymers are also examples of conductors. So what is the role of conductors? They allow the passage of electricity through them. Okay, then they are called as conductors. Next is what? Next is insulators. They are called as insulators, or it is called as non-conductors also. What do you mean by non-conductors now? The substances which do not allow the passage of electricity to them, they are called as non-conductors of insulators. For example, what is the example? Rubber, plastic. You need to remember the examples. Examples are very important. Then ceramic, glass, wood, wax, etc. Okay, so these are some of the examples of uh, this. Okay, conductors. That is, what is conductor? We have seen. What is insulators? We have seen. Now, what do you mean by semiconductors? What do you mean by semiconductor then? What do you mean by semiconductor? Semiconductor means what? Yes, what do you mean by semiconductors? This you have already studied in physics. Semiconductors. So their conductivity will be in between that of conductors and insulators, right? Their conductivity, their conductivity will be in between. The conductivity will be in between. It will be in between the conductors and insulators. So if the conductor, if the conductivity is in between the conductors and the insulators, then it is called as semiconductors. So these are called as semiconductors. Okay. So just few points which I have missed, I am just explaining. Okay. So I've told about non-electrolytes also. Then I've told about strong electrolyte, weak electrolyte. What is degree of dissociation? Okay, there is something called as degree of dissociation. Degree of dissociation is the total number of molecules of the electrolyte which ionizes in the solution. It is given as alpha. Okay, degree of dissociation is given as alpha. Alpha is the number of molecules dissociated into ions upon total number of molecules, of electrolytes. Okay, so it is called as what? It is called as degree of dissociation. So total number of molecules of electrolytes. Okay, for strong electrolytes, the alpha will be equal or approx to 1, and for weak electrolytes it will be less than 1. Okay, for strong electrolytes, the degree of dissociation will be equal to 1, and for weak electrolytes it will be less than 1. Okay, so this is about the degree of dissociation. Okay, so these are some of the terms. So we'll be discussing few more. What do you mean by resistance? Do you know what do you mean by resistance? So these are all terms you have studied in physics also. Okay, so what do you mean by resistance? The resistance of the substance, okay, whose length is 1 meter and they have 1 meter square cross sectional area. Okay, then it is called as meter square. That is, it is called as resistance. What is the unit? If it is a measure of obstruction which is caused by material for the flow of current through it. Okay, the SI unit of resistance, you have to remember SI unit. SI unit is ohm. Okay, ohm. Then what is conductance? Conductance is what? It is the inverse of resistance. What will be the SI unit? It will be per ohm. Okay, per ohm. So, so these are some of the important points. Okay. So in the next class, we'll be discussing about the cell representation. Okay, so these were some of the important points which we have discussed today. So in the next class, we will be learning about the remaining points. Okay, so is it clear whatever has been taught today? about the galvanic cell. Okay, so these are some of the important key terms which we have discussed today about the electrochemical cells. What is galvanic cell? What is electrolytic cell? Okay, electrochemical cell. What is anode, cathode? What is how do you calculate EMF of the cell? Okay, what is electrochemical series? Molar conductivity. Okay, so so these are some of the important key features which we have discussed today. So the remaining part I shall discuss in the next class. I hope it is clear. Yes. So, okay, about the blueprint, so I'll just go through the blueprint and I shall discuss in the next class. Okay, fine. So I shall end the session here. So we'll meet in the next class. Okay. So thank you. So we shall end the session here.